Given a trombone has a tube length with the slide closed of 115 inches, what is the lowest frequency note possible given the slide is kept closed assuming a speed of sound of 340 meters per second? What are the first and second overtone frequencies? So a trombone is basically an open pipe. It's pretty obvious that it's open at the end that we think of the sound is coming out of. But it's also open at the end where the player places their lips, because that mouthpiece is basically just an opening where the player buzzes their lips to create the resonance of air inside the trombone in the form of a standing wave. Now, the formula that I always remember for standing waves that are corresponding to a pipe open at both ends is the wavelength formula. Lambda is equal to 2L over N. Sometimes I forget this formula and I'll draw a few pictures of the fundamental standing wave, the first harmonic, second harmonic, and then pretty soon I'll convince myself this is the correct formula if I ever forget it. The formula I can never remember is that other formula that was on the key concepts slide, so I usually use this to get there, and that was the formula for the frequency. And the frequency, we know that lambda f is equal to v, so f should be v over lambda, was what we did with that. And then you can use this expression, put that in here to get an answer, and that should look like v over 2l multiplied by n, or I think on the key concept slide we had the n first, but it doesn't really matter where it goes. And so what do we have to do here? Well, we're given v is 340 meters per second, and I think we're given l as 115 inches. So that 115 inches, though, it might make sense if we convert that into an SI base unit. So we'll take 115 inches. Maybe I'll just write that like that, and then I can do some conversions here. There's 2.54 centimeters in an inch, and then there is in a meter 100 centimeters, so I'm really going to divide by that 100. So now I'm going to get my calculator to help me do this, and my calculator gives me the answer of 2.921, and that's exactly the answer that it gives me, so it should be in meters. So I'm just going to use that without rounding because this is an intermediate result. And then when I look at the question that's asked here, we're asked for the lowest frequency note. Well, that corresponds to n is equal to 1. So for n is equal to 1, the frequency should be equal. I'm going to follow this formula right here. 340 meters per second is v. I'm going to divide by 2 times 2.921 meters, and then multiply by n. In this case, that's just 1. I'll still write here times 1 just to note that we thought about that, but that's optional if I want to enter it into my calculator. And my calculator gives me a result for this of 58.199 and so on, and it looks like maybe 3 sig figs is okay, maybe 2, it's debatable. I'm going to go with 3 here and say that this is 58.2. I expect hertz to be the correct unit here since we're talking about a frequency and I did everything in base units. And I think that makes sense because the meters cancel and there's that 1 over second that really gives me the hertz. Now, when it asks for the first and second overtone frequencies, first overtone is second harmonic, so that means n is equal to 2. So we're going to do almost the same calculation here, 340 meters per second divided by 2 times 2.921 meters, but now we're going to multiply by an n of 2, and my calculator says 116.398. Maybe I should just round that off to 116 hertz. It hurts me not to put 116.4 for some reason. Okay, that was a really, really bad joke there. N equals 3. That is going to give me that second overtone, because second overtone is third harmonic. So for that one, we do 340 meters per second divided by 2 times 2.921 meter, but this time times 3 for the harmonic, and my calculator says 174.59, so maybe we'll make that 175 hertz, and then we can compare those answers to what the slide says, possibly being tolerant of any rounding issues, because it looks like, I guess it did hurt me as much as I said that it was going to when I wrote this slide. I decided, since I'd rounded this one to the 10th place, I wanted to do that with all of them. And of course, following significant figure rules, I'm not supposed to do that, and I did anyways.